over here, and this is the 2021 Stanford Math Tournament Number Theory section, question number 8. Here's a view of this problem. Compute the remainder when this expression is divided by 2020. So one strategy we need to know is Euler's theorem, which states that a to the power of phi of n is congruent to 1 mod n, where our base a and the modulus n are relatively prime. So let's first reduce this a little. So we can basically reduce the bases. This becomes negative 2 to the 2019 to the 2020 plus negative 1 to the 2020 to the 2021. The 2020 will cancel because it itself is a multiple of 2020. And then this will become 1 to the 2020 to the 2019 and 2 to the 2021 to the 2020. Okay, so now our next strategy will be to reduce each of these modulo 2020. So let's first start with the left. So let x equal negative 2 to the 2019 to the 2020, which will just be equal to negative 2 to the 2019 to the 2020, because this number is obviously odd, and raising negative 1 to an odd power will give us the negative 1. Okay, so now what we want to do is we want to reduce this modulo 2020. Well, we can't use Euler's formula right away because we need 2 and 2020 to be relatively prime, and that is not the case. So what we do is we prime factorize 2020 as 2 squared times 5 times 101, and then we choose to reduce these in like 2 different factors such that they multiply to 2020 and it's a little easier on us. So we choose to reduce x mod 4 and then x mod 505, and then we can do something called the Chinese remainder theorem to find x modulo 2020. Great. So x mod 4 will obviously be 0 since this is going to be a multiple of 4. X modulo 505 is where we need to now do our Euler function, and we can do that now since we have a base of 2 and a modulus of 505, which are relatively prime. Great. So now let's go do this Euler phi function, phi of 505, and then we can break down the Euler phi formula, which is just like, I have another video, I believe, where I explained this, and then we can find out this is 400, so we can do the setup. 2 to the 400 is congruent to 1 modulo 505. Okay, so the next step logically is, alright, how many 400s will fit into this 2019 to the power of 2020? And that's exactly what we're trying to do here. Because we know that we can take multiples of 2 to the 400, and that'll always reduce to 1. So all we're really interested in is the remainder of 2019 raised to the power of 2020 when divided by 400. And that's the exponent we're going to be curious in. Alright, so we can do this, and then as usual, we can reduce the base to 19 to the 2020 modulo 400. Okay, so 19 to the 2020, the way we're going to reduce this modulo 400 is to write it as a binomial expansion. And then if you're astute, you may realize that this is going to be good since now we can, anything with a 20 squared or a higher exponent will reduce to 0 upon modulo 400. So we apply the binomial theorem, 20 to the 2020 minus 2020 times 20 to the 2019, and then the negative 1, but we just brought it over here, and then plus all the way until we have the 2020 times 2020 choose 2019, which is just going to be the 2020, and then the 20, and then that negative 1 to the 2019 will be that negative 1 over here, and then finally the plus 1 at the end. And when we reduce this modulo 400, everything, as I said, with exponent of higher 2 or higher will cancel. So we're just left with this at the end. And then we can now do the calculation. We know 2020 is going to be congruent to 20 mod 400. So this is itself a multiple of 400, so we just get 1. So to reiterate, now if we go back, we found that this is going to be 1 modulo 400, meaning that we'll have just a 1 over here. So this is just going to be negative 2 modulo 505. So now we need to recall that we found x is congruent to 0 modulo 4 and x is congruent to negative 2 modulo 505. Now what we can do is we can test to find the value of x that works, and it's not going to be really hard, right? So we know that x must be a multiple of 4, and then just like cycling through, okay, obviously x has to be, it can't be 503. Next we try negative 2 plus 505 times 2, which is 1008. and 1008 will be like 1000 plus 8, which are both multiples of 4. So that's going to be multiple of 4 and congruent to negative 2 mod phi of phi. So we can conclude that our x is congruent to 1008 modulo 2020. So similarly, what we'll do is we'll now tackle this guy over here, using the exact same steps which I encourage you guys try, and we'll get that y is congruent to 1012 modulo 2020. So now on our final page, and then this was just the requested what we want, like this part over here. This is what we want. This is just 1008 as we said. Now these guys, this is an even exponent, so this is just going to be 1. This is going to be 1 obviously, and this is 1012. Adding, we get 2022, which is congruent to 2 modulo 2020, and that's our answer.